Hello everyone, I want to welcome you all to my talk today. The title of my talk is CI/CD Agility and Controlling Pipeline Sprawl. As developers, we are consistently under the gun. We're consistently being pressured to produce high quality software and releases of that software so that it can be deployed to our customers, users, and folks who are just basically using these services and applications. And I wanted to take a moment to kind of look at that word agility and what it means and the definition of it. So the definition of the word agility is the ability to move quickly and easily. And that's all well and good, right? But we're in the DevOps space, and we need to actually think of agility in a different context. And I wanted to add a definition for the way that, we generally as developers and operators think of the word agility. So what I did was I put a little spin on the definition, and I used obviously the original definition of the word agility and just added the word continuously, because that's basically what we're doing in DevOps. And it just kind of shows that not only are we moving quickly and easily, right, sharing to make the work as easy as possible for folks to accomplish, but we also have to keep a cadence, right? A pretty efficient and high velocity cadence, which means we're constantly developing software, we're constantly pushing code, we're constantly releasing that code. So the mechanisms that we use to facilitate, that agility and that high velocity are CI/CD tools. This is automation, right, that helps us establish and maintain that high velocity and that agility that I'm speaking of right now. The problem is the CI/CD tooling that we're using generally is not perfect, right? There's no such thing as perfect software. We all know that. But what I want to address today is some of the obstacles from the CI/CD tooling that we actually encounter. And I also want to cover some concepts when we're dealing with tooling, not necessarily the actual tools themselves, but some of the concepts around building out pipelines and workflows within our CI/CD processes. Before we get into that, though, I want to introduce myself. My name is Angel Rivera. I'm a developer advocate for CircleCI. And in my role at CircleCI, I basically engage the developer community. I understand how people are using technology and different, software stacks or even cloud providers, right? And technology in general, so I can understand some of their pain points and also share some of my advice if I have any experience with any of the topics that we're discussing. But overall, the job is an awesome job. It's relatable to developers, and I really enjoy the interactions. Now, I built this talk based off of some of the conversations that I've had with these folks at different events or at different occasions. And one other thing I wanted to stress before I leave is if you ever want to reach out to me after this talk, or after this talk, just go ahead and ping me on Twitter. My handle is @punkdata, and I'm more than happy to have conversations with anyone on pretty much any topic. So, like I said before, I'm a developer advocate. This talk was based off of conversations that I had in the past and present with folks regarding their CI/CD processes and and overall just the whole continuous integration, continuous delivery, or a continuous deployment paradigm. So one of the overarching themes of this talk is going to be about managing pipelines at scale. And what I mean by that is, companies usually start off implementing some sort of automation, CI/CD tooling, and generally it starts off at a low-hanging fruit, maybe at a small scope or a small scale, a couple applications, couple code repositories that are being processed through this automation. But eventually, over time, that volume will grow, right? You're going to start adding more and more of your repositories and code bases to the tooling, and you're going to automate a lot more pipelines, right? And eventually that's going to grow into a huge undertaking, right? And what I want to talk about today are two kind of topics within that whole managing pipelines at scale concept. The first thing I want to talk about is pipeline optimizations, where I'm going to discuss some of the things people can easily implement within their CI/CD pipelines to help optimize things and make things more efficient for themselves. And the next topic I want to talk about is going to be about pipeline sprawl. And that's where, kind of managing pipelines at scale will come into a little bit more focus. But pipeline sprawl is just the way I define how things can get out of control within your CI/CD tooling and the configuration syntax that goes along with it. So here's basically a quick overview of the topics I'm going to touch on regarding pipeline optimization. And discuss resource classes. I'm going to talk about concurrent jobs, caching, and selective job processing, which is basically some strategies on how to look at your workflows and then decide how you're going to execute those within your pipeline. Let's start first off with resource classes. And the definition I'm using for resource classes are basically the compute nodes, right? So when you're running CI/CD tooling and automation, you're running this in a server or in a compute node on a cloud provider. In any case, we're running code, right? Because the automation just dictates it. And some of the problems that people have when they're running CI/CD pipelines and workflows on these compute nodes is that they don't adequately size the compute nodes. So if you have an application that relies heavily on like compiling, you definitely need a machine that's really beefy, right? Has adequate resources, actually more than adequate resources to complete those tasks in a timely manner. I can't tell you enough how many people I run into have these conversations with them, and they tell me like, Angel, I don't use the proper compute node because of costs, right? They feel that it's a little bit expensive, or they're looking at that. It's like that sticker shock, right? But I can tell you from experience that if you have an application that requires heavy compute or heavy resources, you definitely save more money, or at least get close to being flush by executing those commands and using higher class resources. So meaning, just use the compute nodes that have the capability to support what your application requirements are, or hardware requirements are, right? Like if you need more CPU, get a higher class rate or higher rated class of compute node to help with that. If your application uses more RAM than CPU, then get a machine that has plenty of RAM. I would say go to by a 10% or 20% more over of your capacity or requirement. That way you kind of covered. And the way that you kind of save money is by if you execute these commands and compile this code on this more costly resource, you're definitely going to end up executing things faster, and so you're using less time, which actually usually is cheaper or really, really close to what the costs are if you were going to run it in a lower grade resource class. So the other topic I wanted to talk about to help with optimization is concurrent jobs. So a lot of folks build jobs, and they build these dependencies on these jobs, which I have to tell you is a big mistake. And I think they make this connection with their jobs and the processes in their minds, and they're constantly kind of I want to say a little bit fearful or cautious about running some jobs in a unsequential manner. But I can tell you that by running your jobs in parallel, you can save a lot of time, obviously, right? Because it just makes sense. It's like multitasking. You're doing multiple things at the same time. So you're going to finish faster in most cases. So what I would recommend is avoid building job dependencies. So think about what it is that you're trying to accomplish and ask yourself, does it really need to be dependent on a previous step in my build process? A lot of times, if you really sit down and look at it, the answer is gonna be no. These things can run in parallel and they don't need to be dependent on that. I can give you an example. So when I generally deploy applications to Kubernetes, or if I'm using a Kubernetes cluster, I have to build a Docker image, right, from my application. And I also have to create a cluster, maybe using infrastructure as code. So when I'm doing those processes, what happens there is I visualize like, all right, do I really need to like build a Docker image, then build the cluster, then deploy that, right? No. The answer is you can do unit testing, you can do security scanning, and Docker builds, and creating this, this infrastructure all at the same time. And then you can set up a dependency point when you need to deploy the application. So in order for the application to deploy, all four of those other things need to be accomplished. So that's what I mean by avoid building job dependencies, or at least limit them to or minimize them so that you're not blocking yourself, because that's what these dependencies are going to do. They're going to create blockages, and that means your time for build is going to, the duration of your build is going to increase exponentially. So the next thing I want to talk about is caching. This is a really tricky one, and the reason I say that is a lot of folks just cache everything, and that's not a great strategy. And the reason why is there are things that you definitely need to cache, and I totally agree that you should be caching that. But there are other things that you really don't need to cache, or you're just caching too much. And remember what caching is. It's basically you're just saving a snapshot of a folder or of some files that you generally use within your builds, and you just want to keep reusing, right? So you're not downloading it from the source every time. You're just basically mounting it into your pipeline build, and it's readily available. It's much faster than having to download all those dependencies every time. The problem is you start, accruing a huge volume within those cached repositories, and then you're basically just downloading gigs and gigs and gigs of dependencies, which again will eventually tack on time to your builds. So what I recommend you do is, cache judiciously. Make sure that you look at what's needed in your applications, and also set up updating strategies. So like if you're running NPM, right, or an application with Node and you're using NPM, you can actually leverage NPM to just update the things that have changed in that cache repository, right? So if you have some dependencies that are newer, that's great. Just leverage updating the things that change, and that will help maintain, a smaller volume of dependencies, and also keep your cache updated with the latest and greatest, so that you're not going back and forth, on trying to figure out how to accomplish this without growing that repository in size. And again, that will tack on more time to your build, and it'll become eventually inefficient. And finally, I want to talk about, in the optimization space, I want to talk about selective job processing. And what I mean by that is, I encounter tons of folks that run all the tests all the time with every pipeline build. And you're probably saying to yourself and me, well, Angel, I've been told that I must run my tests all the time. So you're telling me not to do that all the time? What I'm saying is discriminate against your tests, right? And what I mean by that, again, is look at the test, figure out what's going on and what needs to be tested. Because, some tests are actually redundant in a sense, right? They never change. They're always outputting the same values or the same results. And, do you really need to be running those tests? So I would look at the tests, kind of figure out which ones are important at what stage of the build. You don't need to run all the tests all the time. And, also use conditional job execution. And conditional job execution is basically build out some strategies, specifically maybe in testing, right? Like, do I need to run my unit and smoke test every time on every build? Depending on what stage you are at in the release process, you could use a conditional job, right? So you can say, we are in kind of the developmental phase. We're not really pushing it into the next phase. Let's say it's a staging, right? You're pushing the staging. As long as the condition is that it's in a development mode, you can actually just keep running, smaller tests, more useful tests, and not the more expensive, more comprehensive tests that you would run. Like, let's say if you moved the process into staging, once the build gets promoted to a staging kind of situation or condition, then you can go ahead and run a more exhaustive test before you move into the deployment into production. So just keep that in mind, right? Conditional job execution. That's what I mean by that. So it's like a if this, then that, right? Just keep that in mind when you're building pipelines. I promise you, it will help you kind of figure out what's important in your pipelines and then cut out all the extra fat that you don't need. And one other thing I wanted to leave you with is I've kind of learned this through one of my colleagues at CircleCI. Set some target build duration goals, right? So if you set some standards and timelines that you want to adhere to at all times, or at least a goal to achieve, then you're always going to build efficient pipelines, or at least try to. Now that's not always necessary, or not always that can't always be accomplished by folks who are deploying to cloud providers. Obviously, right, if you're building a Kubernetes cluster in a cloud provider or in a cloud provider service, it's going to take time. So you can't really set, like I like to use the 1 minute rule, which is what my colleague kind of showed me. It's just a goal that you can kind of target. Doesn't mean you will always achieve it. And that's what I mean by, setting some target build durations that you can achieve, or at least get close to achieving. And it's okay if you bust some of those, right? But try to keep them at minimal or as close to that target as possible. So let's recap real quick on the pipelines optimization piece before we jump into pipeline sprawl. So of course, resource classes, right? Just get adequately sized compute nodes. And just use what you need, right? What you actually need. Concurrent jobs, right? Just run your build jobs in parallel and avoid dependencies where you can. Caching, cache cautiously. Make sure you understand what your caching strategy is and how it's being implemented, and always keep an eye on the size of your cache and try to figure out more efficient ways to manipulate and utilize that cache. Also, selective job processing, as I mentioned, right? Figure out what tests need to be run during what stage in your pipeline. So that helps with kind of keeping the redundancy execution of redundant tests down to a minimum. So let's talk about pipeline sprawl now. This is going to be a pretty interesting topic because, believe it or not, most people who use CI/CD tooling have this problem, or at least suffer from pipeline sprawl. So most CI/CD tooling has to have some way of triggering your pipelines. And in order to trigger a pipeline, you need to have some sort of definition, right? Or some template or some blueprint for your CI/CD pipelines within that system. And generally, they're implemented or defined in what we call a configuration file. Now, this is not set in stone, like this math here, what I'm showing you, but the ratio is usually 1-to-1. And again, there's exceptions, but in general, most of the people I speak with when they're using CI/CD, they have a ratio of 1-to-1. And what I mean by that is you have one code repository to one pipeline configuration file. Again, this is in general the majority of what I've kind of encountered in my conversations with folks who are using CI/CD. So Another kind of truism is most most modern CI/CD tooling leverages YAML as their kind of syntax of choice. Now, contrary to popular belief, YAML is not a programming language. YAML is a data structure. It's a declarative data structure, and it's been adopted by the cloud native kind of genre or paradigm, and it's used in all over cloud native type solutions these days. And of course, right, like I mentioned earlier, YAML is a data structure. But the problem with YAML is it's a data structure and it doesn't really have reusability, right? So if you think of YAML as a similar data structure to like JSON, obviously the syntax is different, but kind of the same standards apply. It's a data structure. The syntax in YAML can become very redundant. And when you're doing CI/CD, declarations within YAML for pipelines, you're going to get a lot of repeat and a repeat functionality and calls, right, and repeat values within that YAML. And again, since there is no kind of reusability within YAML of values, and it's a data structure, these files can kind of grow in complexity and in volume. So that means as you add more functionality to your CI/CD pipeline configuration, you're actually growing it, adding more lines of code and syntax to that file, and eventually it becomes unmanageable, right? Or at least very difficult to manage. And it's hard to navigate. It's hard to find, where where you should make changes or where problems are occurring. It's just, again, like a lot of code, and eventually, right, a human being will have trouble navigating it. So when you have that situation, I call it a configuration repo sprawl, right? So that means, you're basically having a lot of syntax, a lot of code bases, and it's growing out of control, right? Like I said earlier, eventually you start off with a small amount or small volume of repositories and syntax, and then eventually it just grows into something that becomes out of control. And it becomes difficult to maintain as well, right? So you're sitting there again, trying to figure out, where in the code is a specific execution command that you need to kind of address. Then you're hit with this configuration repository dilemma, right? Like, so how do I manage all of these things? I've talked to folks that, mentioned, well, you just implement GitOps and that should help you. But that's not the answer, and it's not a viable solution for this particular problem. So what are our options? What can we do, Angel, to get a hold of this pipeline sprawl? One of the things I sat down and started looking at, I'm a developer, and I sat down and started looking at this problem, and right away I got the idea of I can handle this by separating the concerns. So if you implement object-oriented programming kind of concepts and paradigms, a separation of concerns is where you basically go in and look for common patterns, right? Things that are repeating and happening over and over again in your pipeline. Then you can create abstractions so that you can isolate that functionality, right? And then create an encapsulation, meaning, when you have that isolation, now you can create a repeatable process, and you can encapsulate it so it's in a very manageable kind of a piece of code, right? And once you get to that point, you can then start adding parameters, right? So now you can define some properties, and once you have those properties, you can now start parameterizing, meaning you can swap out those values for those properties, right? And that becomes a reusable, modularized code base. So that turns something like this hard-coded command. This is a good example of a config file that's hard-coded in CircleCI. And if you look down into the command key there, what you're going to see is basically a simple S3 upload. And as you can see, right, that app version 10_2 jar is a hard-coded value. And with encapsulation, right, you won't have to hard code. You don't need to hard code those commands anymore. And imagine if you had to hard code those commands. Let's say you have 1,000 repos, and then you have 1,000 config files for every repo. So if you have that same AWS commands and all of those files, and you had to make one change, that would span across all those repos and all those configuration files, you're basically either going to have to write a script to automate that, or you're going to have to do it manually. Now, if you write a script, you have to be sure that you're updating the right spot in the file as well. So there's a lot of complication to that. My solution to this is pipeline libraries. This is where you would create, like I said, a mechanism to go ahead and give you the ability to kind of reuse code, number one, and also give you that variability within your execution commands. So now, if you take a look at this example, at the lowest run command there, if you recall, what I've done is I encapsulated functionality into a couple things: the environment variables there for the jar file, and then the AWS S3 bucket. I basically created some variables so I get some ability to make parameters, right? And then I've also implemented that functionality to kick off that command, that upload command, into a bash script or a script, right? So that's more code kind of encapsulating all that. And now I can just supply those variables that are changing in my runtime right to that script, and that same functionality will occur consistently every time, right? But obviously the values will change, and it'll target the appropriate resources that I'm trying to make a transaction on. So with encapsulation and portability and making things more module-wise or more modular, more portable, you're creating also a centrally managed functionality. So not only will you reduce the amount of code across your pipelines and in your configuration files, you're also giving yourself the ability to kind of do a one-stop shop management of that code. So if you need to make a change, no longer will you have to change 1,000 config files. You can just change that one master template dependency or encapsulated file or functionality, and it will propagate over to all of the assets that actually implement and use that script. Again, right? So this will add portability, minimizes, and it also minimizes vendor lock-in. And what I mean by that is, if you hard code things into your CI/CD syntax or pipeline config files, then it's literally locked into that file, right? But if you abstract it out into what I propose is like a pipelines library, then basically you can minimize the vendor lock-in. So you can take that same code base, and if it's Bash, if it's Python, if it's Go code, it's going to run on any runtime that supports those frameworks, right? So now you're no longer locked into a specific vendor when it comes to CI/CD tooling. If you want to use CircleCI, great. If you want to use something else, you can do that as well. And bring that scriptability or that portability. Take your scripts with you, kind of thing, and then run them right. However, they're supposed to be run on this new platform. Now, we've actually implemented what I'm talking about in CircleCI. We created this feature/product called Orbs, and basically what it did was gave us that functionality that I'm talking about. And not only do we get that functionality of reusable like configuration, we also have the ability to host this in what we call a registry, which is again that centrally managed location. So if anyone needs to make any changes to those orbs, they can do it in one place, and then there'll be a new version, and now you can leverage that new version and that new functionality without breaking all the old stuff, right? So by using a versioning component, we can also reduce the amount of breaking changes. So now that I kind of that I covered pipeline sprawl, I'm just going to do a quick recap on it so that folks will understand and hopefully remember what I've said. So with pipeline sprawl, right, it's great for identifying common patterns or in pipelines. So you want to do that to create that encapsulation and functionality and get that parameterization going, right? And if you implement that into scripts, that's great. Like I said, you could use any kind of language, Bash, Python, Go, JavaScript, even depending on what you're comfortable with or what your team is comfortable with. You can use those scripts to consolidate and centrally manage that code. And then finally, again, it will help you with vendor lock-in and minimizing those effects, right? And it also adds that portability that some of us, or actually say most of us, might need. Whether you know it or not, eventually, right, you're going to be impacted by either vendor lock-in or portability. And it sucks when you have to, figure out solutions for those. So that's the end of my talk. I hope everybody got something out of this. And if you need to reach out to me, please feel free to hit me up on Twitter. My Twitter handle is @punkdata, and I'll be more than happy to speak to all of you. Thank you so much. Have a great day.